You ever wonder how a weightlifter can just hoist 500 pounds over their head, but would be totally gasping for air a mile into a run? Or, flip that around, how a marathoner can go for hours and hours, but might seriously struggle with one single explosive box jump?
Well, it's not really about being in shape or out of shape, it's about being specialized. It all boils down to how your body is wired to spend its energy for different tasks.
Hey everyone, and welcome to Subject Simplified. Whether you're an athlete, a student cramming for an exam, or you're just kind of curious about how your body works, we are about to decode the science of energy. We're going to break down exactly how your body fuels everything from a massive deadlift to a grueling marathon.
So, here's our game plan. We'll kick things off with the body's universal energy currency. Then we'll get into our three main engines, the instant power boost, the one that really makes you feel the burn, and of course, the long haul engine. After that, we'll look at how you can actually level up your system with training and then touch on a few special conditions you got to keep in mind.
All right, first things first, let's talk about money. Or more specifically, the only type of currency your muscles will accept to do any work whatsoever. Let's meet ATP. So yeah, the fancy term is Adenosine Triphosphate. But honestly, all you really need to remember is that ATP is like the universal cash for your muscles. It's the only thing they'll accept to do any work. And I mean anything, from a heavy lift to just blinking your eyes. It is the energy that's ready to go right here, right now. Okay, so let's walk through this power cycle. Just think of ATP as a fully charged battery. When your muscle needs power, bam, that ATP breaks down, releases a burst of energy, and becomes ADP, which is basically a dead battery. But the magic happens next. Fuel from your food or from something called creatine comes in, slaps that phosphate back on, and boom, it's ATP again, fully recharged and ready to go. And this isn't a slow process. This cycle is happening constantly, millions of times a second inside you. Now, what happens when you need a massive amount of energy, like right now? Well, your body hits the Nitro Boost button. And that, my friends, is the ATP-PC system. This system is all about pure, unadulterated, explosive power. We're talking maximum effort that lasts for 10 seconds or less. It's anaerobic, which means it happens so fast, your body doesn't even have time to use oxygen. Instead, it runs on this special high-energy fuel called phosphocreatine, or PC. Think of it like a pre-packaged booster that instantly recharges your ATP. This is the system that powers a 100-meter sprint, a single heavy power list, or a powerful golf swing. But here's the catch. After that 10-second burst, the tank is empty. And it takes your body anywhere from 30 seconds to a full 4 minutes to completely restock that phosphocreatine. This is exactly why you see powerlifters resting for several minutes between their heavy attempts. They're not just chilling out. They're literally waiting for this high-speed fuel to regenerate. Okay, so your 10-second power boost is completely spent, but you're not done yet. You gotta keep going hard for another 30 seconds or so. What happens now? Well, your body shifts gears into our second system, the lactate system. So let's break this down. The process is called anaerobic glycolysis. Your body still needs ATP super fast, so it's still anaerobic, no oxygen needed. But this time, instead of using phosphocreatine, it starts tearing through stored carbohydrates, or glycogen, to make that ATP. It's a fantastic backup plan, but this kind of messy, rapid-fire process creates a byproduct you've probably heard of, lactic acid. And this quote just hits the nail on the head. You know that intense burning sensation you feel when you're pushing through a really tough workout? That's not a sign of failure. It's a direct signal that this lactate system is working overtime. Lactic acid is building up, and your body's letting you know you are pushing your anaerobic limits. The crucial thing here is that this system acts as our high-intensity bridge. It can buy us up to about 90 seconds of really hard effort when that first system is totally tapped out. This is the engine that powers a 400-meter sprint, often called the most painful race in track, or an all-out shift in a hockey game. Your heart is pounding, and the gears are turning as fast as they possibly can without oxygen. So, we've got a 10-second system and a 90-second system. But that begs the question, how on earth do marathon runners and triathletes keep going for hours and hours? Well, they tap into the body's most efficient, most sustainable power plant, the aerobic system. The key word here is aerobic. This system requires oxygen, which makes it a little slower to get going, but man, is it efficient. It can burn both carbohydrates and fats for fuel, which is a massive advantage for endurance. And this whole incredible process takes place inside the mitochondria, the legendary powerhouses of your cells. This is the go-to system for low to moderate intensity exercise that lasts longer than a few minutes. Think marathons, triathlons, long bike rides, you get the picture. Now, I know, this looks super complicated, but just think of it as a 3-stage ATP factory. It starts with aerobic glycolysis, moves on to the Krebs cycle, which is probably the final boss in your textbook, right? And then finishes with the electron transport chain. You don't have to memorize every single step. Just know this. The big takeaway is that this clean, oxygen-fueled assembly line produces a massive amount of sustainable energy. So we know the 3 systems now, but here's the magic part. You can actually train them. With the right kind of exercise, you can literally level up each specific system to get better at what you do. Your body is just incredibly adaptive. For instance, if you do consistent sprint training, your muscles will literally start storing more creatine. That gives you a bigger nitro tank. Do a lot of high-intensity interval work, and your body gets way better at clearing out lactate, so you can handle that burn for longer. And of course, endurance training, it literally builds more and bigger mitochondria, more power plants, so you can efficiently burn fuel for hours on end. You're basically upgrading your body's hardware to match whatever you throw at it. Finally, it's really important to know about a few special conditions that can throw a wrench in these systems. You can think of them like variables, or if you're a gamer, debuffs. 2 key ones to remember are diabetes and age. For an athlete with diabetes, careful management is crucial because exercise can cause a really rapid drop in blood sugar, which is known as a hypoglycemic attack. And then on the other end of the spectrum, you have children. Their lactate system isn't fully developed yet, which means they're actually less efficient during those sustained high-intensity activities when you compare them to adults. Okay, if you're studying for a test, pause here. Take a screenshot of this slide. This is your ultimate cram sheet, summarizing everything we just talked about. You can see that perfect relationship between duration and intensity. The ATP-PC system, it's maximum power for just a few seconds. The aerobic system, sustained lower output energy for hours. And that lactate system is the critical bridge right in between the two. You know, the most important thing to take away from all this is that no single system is the best. They all work together, constantly passing the baton back and forth. A basketball player might use their ATP-PC system for a huge jump, their lactate system for a fast break down the court, and their aerobic system to jog back on defense, all in a single play. So the real question is, now that you know the science, how are you going to train your engine for your goals?
Hey, if this breakdown helps simplify your studies, do me a favor and hit that like button. And be sure to subscribe to the Subject Simplified channel for more deep dives into complex topics. Thanks for watching.